Have you ever looked up at the night sky and just, wondered
Hmm.
about reality itself, where it all came from, or if science really does have all the answers?
It's one of those fundamental human questions, isn't it?
Absolutely. And today, we're looking at a book that tried to tackle those huge questions head on. Stephen Hawking's The Theory of Everything.
Right, a very ambitious title and an ambitious book. Popular science, theoretical physics, aiming high.
Exactly. Now, just so you know what you're experiencing here, this is a unique two-host AI conversation. We're powered by Google's NotebookLM, and the whole idea is to give you a deeper, more dynamic book critique.
Yeah, we're not just summarizing. We want to understand the insights, sure, but also the limitations. Really analyze it.
We want to guide you through it critically.
And it helps to remember when this came out, right? 2002.
Oh, good point. Context matters.
Definitely. It was peak optimism, kind of, for things like string theory. This big push for a grand unified theory.
Following in Einstein's footsteps, trying to get that one equation for everything.
Precisely. And Hawking was right there, leading the charge in many ways.
Okay, so let's unpack the book's big claims. What was Hawking actually asserting, and, importantly, what evidence did he offer?
It's a real spectrum. Some stuff is rock solid, some more out there. Let's start with the solid ground then.
Okay, first big one. The universe began about 15 billion years ago. The Big Bang.
Standard model stuff, basically.
Pretty much, yeah. And he presents the evidence really clearly. You've got the cosmic microwave background radiation.
That leftover heat from the beginning.
Exactly, the faint afterglow. Then the redshift of galaxies proof the universe is expanding.
Right. Things moving away from us.
And also the amount of hydrogen and helium we see out there. It matches Big Bang predictions perfectly.
So that claim rests on strong observational evidence, pillars of modern cosmology, like you said.
Absolutely solid. He didn't discover it, but he explained it brilliantly.
Okay, what else stands on that kind of firm ground?
Well, his own huge contribution. The idea that black holes aren't completely black, they emit radiation. Hawking radiation, named after him.
That's the one. His evidence here was theoretical, a really clever calculation combining quantum mechanics, the physics of the small, with general relativity, Einstein's theory of gravity.
Bridging the two big theories.
Exactly. And what's fascinating is, although it started as pure theory, there's been some recent indirect evidence supporting it. So it's looking stronger all the time.
Okay, still pretty solid then. But you mentioned a spectrum. Where does it start getting more speculative?
Right. This is where we move from observation and tested theory into more, let's say, cutting-edge theoretical ideas, like his no-boundary proposal for the universe's origin.
The idea that the universe didn't really have a beginning point. How does he argue for that?
Well, the evidence isn't observational, it's mathematical. It's a model.
Okay.
He uses this concept called imaginary time, which isn't time like we experience. It's a mathematical tool.
Right, I've heard of that. Sort of rotates time into a spatial dimension mathematically.
Kind of, yeah. The goal is to get rid of that initial singularity, the point of infinite density the Big Bang model predicts. With imaginary time, the beginning looks more like the surface of a sphere, smooth, no sharp starting point, no boundary.
Elegant mathematically.
Very elegant. But, and it's a big but, it's still a speculative theoretical framework. We can't, go back and check it experimentally.
Gotcha. Theoretical elegance isn't the same as empirical proof. What else?
Then there's the big claim. A unified theory, a theory of everything, is actually achievable.
The ultimate goal. What's the evidence for that being possible?
This is mostly based on analogy.
Yeah.
Looking back at the history of physics.
Okay.
We saw electricity and magnetism get unified by Maxwell. Then later, electromagnetism and the weak nuclear force were unified into the electroweak force.
Right. Successful unifications happened before.
So Hawking argues, by analogy, that we should be able to do it again. Unite all the sources, including gravity, maybe with something like M-theory.
M-theory, one of the contenders for that unified theory.
Exactly. But it's still an analogy. Just because we did it before doesn't guarantee we can unify gravity, which is, notoriously difficult to combine with quantum mechanics. It's inspirational, but not proof.
Okay, so analogy, not direct evidence. And then the really headline-grabbing one.
Ah, yes. Spontaneous creation from nothing.
That one definitely got people talking. What's the basis for that claim?
He points to quantum field theory, specifically quantum fluctuations, and also predictions from M-theory.
Quantum fluctuations like particles popping in and out of existence in empty space.
Exactly. The idea is that the vacuum isn't truly empty. It's fizzing with potential energy and virtual particles. His argument, drawing on M theory as well, is that the whole universe could have originated as such a fluctuation.
But is the quantum vacuum really nothing?
That's the crucial point. In physics, nothing, or the vacuum state, still has physical laws, quantum fields, potential energy. It's not the philosophical concept of absolute nothingness, the complete absence of anything.
So it's more like spontaneous creation from a pre-existing quantum potential.
That would be a more precise, if less catchy, way to put it.
Yes.
And it remains highly speculative and debated among physicists and philosophers.
So it really is a fascinating journey in the book. You start with stuff we can measure, like the cosmic background radiation, and end up with ideas like spontaneous creation from, well, something that physicists call nothing.
Exactly. A spectrum of certainty from well-established science to the very frontiers of theoretical speculation.
Okay, that map of claims and evidence is really helpful. Now, you mentioned looking at this through an epistemic lens. How does that help us categorize these different kinds of statements?
Right. We're using a framework inspired by Adler to distinguish between opinion, knowledge, understanding, and wisdom. It helps assess the type of claim being made.
Okay, let's start with opinion. What falls into that category from the book?
A prime example is Hawking's famous statement that philosophy is dead.
Ah, yes, that one ruffled some feathers.
Understandably. He argued that science, specifically physics, had taken over the big questions philosophy used to ask. We'd classify this as an opinion, maybe even scientific triumphalism. It's a viewpoint, a stance, not a scientifically proven fact.
Makes sense. It's his take on the role of different disciplines, not a result from a physics equation. What about knowledge?
This is the solid stuff we talked about. The expansion of the universe, the CMB's existence, the basic observed properties of black holes. These are pieces of scientific knowledge backed by strong empirical evidence. The book explains this knowledge very effectively.
Okay, facts based on observation and experiment. Then understanding. How is that different?
Understanding is deeper than just knowing facts. It's about seeing the connections. Hawking showed profound understanding when he linked quantum mechanics and general relativity to describe black hole radiation.
Right, seeing how different theories relate to the bigger picture.
Exactly. He demonstrated a deep grasp of how these seemingly separate domains connect to explain cosmic phenomena. That's genuine understanding.
And finally, wisdom. Where does the book touch on that?
Well, wisdom often involves recognizing limits and embracing intellectual humility. The book approaches wisdom when Hawking acknowledges the limitations of current theories, the things we don't know yet.
But you sound hesitant.
Because that glimpse of humility is often, I think, overshadowed by the very confident pronouncements about things like philosophy being dead or the universe inevitably creating itself from nothing. The wisdom is there sometimes, but it competes with a high degree of certainty about speculative ideas.
So, for someone reading this, trying to grasp these huge concepts, what's the takeaway from this epistemic analysis?
It highlights that even a genius like Hawking can sometimes step outside their area of proven expertise. It shows the importance of distinguishing between established scientific knowledge, deep theoretical understanding, and opinions or speculative claims, even when they come from a brilliant source.
It helps you read more critically, basically, not just accept everything because of the author's reputation.
Precisely, which leads nicely into another tool we use, the Golden Rule assessment.
Okay, what's that? Sounds intriguing.
It's about intellectual honesty and responsibility. Essentially, we ask, would the author accept the same standards applied to their own work as they apply to others, or expect from science generally?
Ah, reciprocity. Like, would Hawking accept claims like spontaneous creation if someone else proposed them without solid proof?
Exactly. Let's look at the scientific method. Would he accept purely theoretical, unverified claims from others as established fact? Probably not. The scientific community's own skepticism about some of his more speculative ideas shows that the standard expectation is empirical verification.
Right, science usually demands proof.
Then think about educational responsibility. Is the book just explaining science, or is it pushing a specific worldview? While it's brilliant at explaining physics, the dismissal of philosophy, does that serve someone genuinely seeking truth from all angles? It arguably shuts down lines of inquiry.
It might fail the reciprocity test there, suggesting physics is the only path to truth.
Potentially, yes. And related to that is public trust. How should we present science to the public? Would Hawking want highly speculative ideas like the multiverse or spontaneous creation presented almost as if they are established facts?
Probably not if you were being rigorous about the scientific method.
Right. Presenting speculation with such certainty risks misleading people about what's proven versus what's still hypothetical, It's a matter of responsible communication.
This is a really thorough way to look at the book. It goes way beyond just, did I like it?
That's the goal, to apply a structured critique.
If these kinds of deep dives inspire you to think more critically about complex topics, you'll find even more thought-provoking content with our Mindful Moments on our YouTube channel.
Yeah, we offer AI book analysis, summaries, and critiques there too, all designed to encourage reflection and rational thought. Definitely check it out.
Okay, let's switch gears slightly and talk about logic. Did you find any specific logical fallacies in the book's arguments?
Yes. Looking closely, a few patterns emerge that are worth highlighting for critical thinking.
Like what?
Well, one clear one is a category error.
Okay, explain that.
Hawking seems to conflate two different categories of explanation: physical causation and metaphysical creation. When he talks about the universe creating itself from nothing, he's using the physicist's nothing, the quantum vacuum.
Which we already said isn't really nothing.
Exactly. But he presents it as solving the metaphysical question of why there is something, rather than absolute nothingness. He's mixing a physics explanation with a philosophical problem, treating them as the same category.
I see. Using one type of nothing to dismiss the need to explain another type?
Precisely. Another one is a false dilemma.
Either thinking.
Right. The book sometimes frames the debate as either you have a scientific explanation, like the Big Bang from quantum fluctuations, or you need divine creation.
But that ignores a lot of other possibilities, right?
Absolutely. It ignores many sophisticated theological or philosophical viewpoints that don't see science and a creator is mutually exclusive. It forces a choice that isn't necessarily the only one.
Okay, what else?
We touched on this earlier, but the argument from analogy regarding unification is logically weak.
Because past success doesn't guarantee future success.
Exactly. Just because we unified electromagnetism and the weak force doesn't logically entail that we can definitely unify gravity with everything else.
Yeah.
It's suggestive, hopeful, but not a deductive argument. Gravity is a different beast.
Makes sense. Any others?
There's a subtle appeal to authority. Because it's Stephen Hawking, his immense scientific stature lends weight to claims that go beyond his core expertise, particularly the philosophical or metaphysical ones.
People might accept his views on philosophy just because he's a brilliant physicist.
It's a natural tendency, but logically, his physics expertise doesn't automatically make him an expert on philosophy or theology.
Right. And one more?
Maybe circular reasoning, arguably in the no-boundary proposal.
How so?
The model is designed specifically to eliminate the need for a beginning or an external cause. By using imaginary time and creating a self-contained universe model, it essentially assumes the conclusion that no external cause is needed within the structure of the mathematical framework itself.
It builds in the answer it's trying to find.
You could argue that, yes. It shows a universe could be self-contained if this mathematical structure reflects reality, but it doesn't necessarily prove it is.
Okay, so that gives us a lot to think about regarding the logical underpinnings. Where does that leave us overall with the theory of everything? It's clearly influential, but also complex to evaluate.
It really is. If we try to summarize the balance sheet, the strengths are undeniable.
Go on.
First, the scientific exposition. Simply masterful. He made incredibly complex ideas in cosmology accessible to millions. This is a huge achievement.
Agreed. He was a brilliant communicator.
Second, theoretical innovation. The book presents his own groundbreaking work on black holes and quantum cosmology. Genuine, original contributions to physics.
Stuff that changed the field.
Absolutely. And third, the inspirational impact. How many people went into science because they read Hawking? How many just looked up at the stars with more wonder? That's a massive positive impact. It fosters scientific literacy, which is crucial.
Hard to argue with those strengths, but what about the flip side, the weaknesses?
Well, as we've discussed, there's the philosophical overreach, making pronouncements on philosophy and theology as if they're settled by physics. That goes beyond his scientific expertise.
The philosophy is dead kind of thing.
Exactly. Then there's the speculative certainty, presenting things like the multiverse or spontaneous creation with a degree of confidence that just isn't warranted by the current evidence. They're hypotheses, not proven facts.
Which can be misleading for the public?
It can. And finally, related to that, a kind of methodological inconsistency. He champions the scientific method based on empirical evidence, but then makes these large metaphysical claims that can't be empirically tested, essentially stepping outside the very method he advocates.
Applying scientific authority to non-scientific or pre-scientific questions.
Something like that, yes. So the overall picture is nuanced.
A masterpiece of science communications, certainly.
Undeniably. but perhaps, as you said, marred by a kind of philosophical naivete, or at least overconfidence. His physics contributions are monumental, his ability to inspire, unparalleled. But the book's limitations are a good reminder, I think, that even the brightest scientific minds can benefit from engaging with other ways of knowing, other traditions of wisdom, especially when tackling those ultimate questions that might lie beyond what experiments can currently tell us.
And it leaves us, the readers, with some really profound questions still unanswered, doesn't it? Things the book touches on, but maybe doesn't resolve.
Oh, absolutely. Huge questions remain. Like the measurement problem in quantum mechanics. How do you apply a theory that seems to need an observer to the entire universe when there's no observer outside it?
Right, the observer effect scaled up infinitely.
Exactly. Or the fine-tuning challenge. Why do the fundamental constants of nature seem so perfectly dialed in for life? Is it just the anthropic principle, we're here because it's suitable, or is there something more profound going on?
A question that physicists and philosophers both grapple with.
Definitely. And the hard problem of consciousness. How does subjective conscious experience arise from purely physical stuff, like neurons firing? What does that mean for a purely physical theory of everything?
Does the theory of everything have to explain consciousness too?
That's a major debate.
Mm.
And finally, the metaphysical foundations. What basic assumptions about reality itself underpin all our physical theories? Are those assumptions testable, or are they the philosophical bedrock upon which science is built?
Wow, so the quest for a theory of everything really opens up even more questions.
It always seems to, doesn't it? The edge of knowledge just reveals a wider horizon of ignorance.
A humbling thought. Now, just to be clear about our process today, our analysis was conducted using a systematic framework. We didn't just react. We aimed to evaluate the book's claims, its evidence, the logic, the broader implications, very methodically.
Right. It helps uncover not just what the book says, but how it says it, and why that presentation matters for your understanding.
We hope this structured approach gives you a genuinely in-depth perspective.
And if you want more analysis like this, book summaries, critiques, explorations of complex ideas, remember to check out Mindful Moments on our YouTube channel.
You can also find more of our podcasts covering a huge range of fascinating topics wherever you get your podcasts.
We really try to stimulate that reflection and rational thought.
So click the link you see on screen for the in-depth book analysis from today.
And please, subscribe, share, maybe purchase the book via the link if you're interested.
And above all, think rationally.